Hello, and welcome to Los Alamos National Laboratory's Math and Science Academy. In this thread, we'll be looking at the Grade 6 Common Core Standard for Number Systems that involves extending understanding of multiplication and division to divide fractions by fractions. In particular, we'll look at the question, how wide is a rectangular strip of land with length 3/4 mile and area 1/2 square mile? In a previous thread, we looked at the first part of this standard, and you may want to go and review that to see some other ways of looking at these kinds of issues. The learning goals for this standard are that the student will create story contexts for a given mathematical task. In fact, in this particular thread, we'll be looking at a situation where the student will be analyzing or interpreting a story context and find the correct mathematical task. The student will be able to visualize and understand dividing fractions by other fractions using different strategies, in particular double number lines, area models, double bar graphs, and ultimately symbols and procedures. And the student will communicate mathematical thinking accurately and with precision. So here's our problem. How wide is a rectangular strip of land with length 3/4 mile and area 1/2 square mile? Often students will see problems like this and just simply multiply the two numbers because they see area, they see length and width, they see two numbers, so they multiply. It's important to recognize that what's given is the area and one of the side lengths, and what's asked for is the other side length. So this ends up being a division problem. We'll start by looking at an area model of this problem. Here's our land. It's got a side length of 3/4 mile, and it's got an area of 1/2 square mile. And what we're after is the length of the other side, the width, which we call it. So we'll start by looking at this in reference to 1 square mile, since that's our kind of nominal unit here is a mile. So we'll look at this with respect to 1 square mile. And you've noticed that I've chosen the units here, the size of things carefully, so that the length of a piece of land is in fact 3/4 of a mile. 3 pieces out of 4 in this direction. And I still don't know what this width is. I just need to know that this has to represent 1/2 square mile. So to standardize this now, we're going to change the representation of the area. It's supposed to be 1/2 square mile, but we don't know what this length is. What we can do is redraw the area so that it is 1/2 square mile. So here's an area that definitely is 1/2 square mile. It's 1/2 of these, but it no longer has length 3/4. But what we've done is we've broken the square mile into individual pieces that are all the same size. And so now we can ask the question, how many 3/4? Here, these 6 pinks represent 3/4 of a mile, of a square mile, or 3/4. How many of those 3/4 are there in a half? Well, again, 3/4 is 6 units, and 1/2 is 1, 2, 3, 4. These 4 units represents 1/2. You'll notice again that this unit of an eighth comes up. You see the 8 parts comes up, this little mini unit. That again is that common factor, or the least common multiple of 2 and 4, the common denominator. At any rate, we know that since 3/4 is 6 units and 1/2 is 4 units, the question is, how many 6's do we, how many times does 6 fit in 4? How many 6's in 4? And the answer to that is 4 divided by 6. How many times 6 goes into 4 is 4/6. And then we can reduce that to 2/3. So we know that our result has to be 2/3, and then if we go back to the area representation, we can know that now the actual land has a length of 3/4 and this width is 2/3 mile to give us 1/2 as our area. Here's our problem again. How wide is a rectangular strip of land with length 3/4 mile and area 1/2 square mile? This time we use a double bar model, which is very closely related to a double number line. We begin by representing 1 square mile as this blue bar, in which case 1/2 square mile, the area that we have in our land, is half of that, so we'll shade that tan here. We also need to represent 3/4 of a mile, so we'll draw another bar, same length, that represents 1 mile, and shade 3/4 of it to represent 3/4 of a mile. Now for the core question of the problem. How many times does this 3/4 fit in this 1/2? We'll answer our question about the width. So again, it's not obvious from the question, but the core idea is how many 3/4 are going to fit in 1/2. In other words, how many times does this length fit in here? And we can see immediately that it won't fit an entire time. It won't fit once. It's going to be less than that, so it's going to be a fraction. The question then becomes, what fraction of this pink fits into the tan? In this case, we're lucky because the fractions have very nicely related denominators. We can break the 1/2 mile into 2/4, which aligns directly with the 2/4 of the 3/4. And that allows us to see very easily that 2 of these 3 fit in to the half, or 2/3 of the pink represents the tan. So another way to say that is that 1/2, this tan, is 2/3 of 3/4, 2/3 of the pink. So now we'll just become a little bit more abstract and use proper mathematical notation. 1/2 is 2/3 times 3/4. And since that's true, since 1/2 is 2/3 times 3/4, we then know that 1/2 divided by 3/4 is 2/3. This is that reciprocal relationship, the inverse relationship, between multiplication and division. So 2/3 is our answer, and we finally write it out by answering the question in the problem. The width of the land is 2/3 mile. We've seen a nice example of images that are somewhat abstract, but that support the concept and ultimately will support the procedure and a deeper understanding of how these things work. So here's our problem again. How wide is a rectangular strip of land with length 3/4 mile and area 1/2 square mile? This time we use a procedure. Procedures are the ultimate goal for our teaching because they're so efficient. However, they're very abstract and they can easily be misunderstood. And so it's important before moving on to procedures to reinforce concepts and really solidify them with images and models and other ways of thinking about the problem. Once we use a procedure, the first thing to do is identify the key idea in the problem. This problem is about area, specifically about rectangular area, and we know that area of a rectangle is the length times the width. Also implicit in the problem is the inverse nature of multiplication and division, because since area is length times width, that's the way students mostly remember area. We also know that width then is area divided by length. That's the inverse of multiplication. So this is the formulation that we will use, and once we identify that, we know that we need 1/2, which is our area, divided by 3/4, which is our length. So another key idea here is that division is multiplication by the reciprocal of the divisor. So multiplication by the reciprocal of the second number, people think of it that way. And so our 1/2 divided by 3/4 becomes 1/2 times the reciprocal of 3/4, or times 4/3. We flip this over here. Now we move on to another procedure that we know, which is multiplication, is multiplying numerators and denominators. 1 times 4 is 4, 2 times 3 is 6, and we have our answer 4/6. However, we always want to reduce to lowest terms, and so with the common factor of 2 in 4 and 6, we'll reduce 4/6 to 2/3 and then answer the question. The land is 2/3 miles wide. For more advanced students, or once they really understand this idea and have this procedure down well, it's nice to introduce them to a shortcut and an improvement on the idea of multiplication of fractions, where instead of multiplying numerators and denominators straight out, we reduce before we multiply. And sometimes this reducing is called cross-canceling. But let's go back. Here's our problem again. And what we notice is that when we do this multiply, we're going to have a 1 times a 4 in our ultimate numerator, and we'll have a 2 times a 3 in our ultimate numerator. And so because the 4 and the 2 both have a common factor of 2, we're going to have a common factor of 2 in the numerator and denominator that we're going to have to deal with, which we did over here, when we're done. Well, it's nice to learn how to deal with those common factors before we multiply. Now, it's pretty evident to reduce a given fraction. So if this were 2/4, students would understand probably that we could change it to 1/2 before we multiply. But what's different here is we can cancel this 2 with the common factor of the 2 in this 4, because ultimately they will be in a numerator and a denominator. Ultimately, you're going to have to do that anyway. So we can do it beforehand, thereby reducing the size of the numbers that we have to multiply. So we'll look at this 2 and this 4, and because there's a 2 in here, a 2 goes into this 2 once, and 2 goes into that 4 twice. We've basically just eliminated that common factor. And now, when we multiply, we simply multiply 1 times 2 and get 2, 1 times 3 and get 3, and we get our answer, 2/3. This is a nice shortcut, and it comes in really handy as we move into algebraic fractions. And when students can get to this level, they really have mastered multiplying and dividing fractions. Of course, at the end of the problem, you always want to check it in. So let's check and make sure that our 2/3 times 3/4, that's our length times the width that we found, will come out 1/2. And I'm going to use reducing before multiplying here because it's going to make my multiply real easy. There's a common factor of 3 in both of these, so I can reduce those to 1s. And there's a common factor of 2 in this 2 and that 4, so I can change this to a 1 and this to a 2. Now I simply, when I multiply across, this number here is just 1, so I'm not even going to have to do this. But basically I get 1 times 1 is 1, 1 times 2 is 2, and I get 1/2, which is the area that I needed. So another place where this cross-canceling or reducing before multiplying comes in handy is in checking, and when it really speeds up multiplication of fractions. So again, procedures come after solidification of the concepts through images and models. However, they are what you want to get to at the end because they're very efficient and they can really move through calculations quickly. Here's some teacher work for this problem. You'll notice that they start out strongly with procedures. The question as stated is, what's the width, here's width right here, of a piece of land, so that when you multiply it by 3/4, the length of the land, you get 1/2 for the area. So width times length equals area. And then recognition that this is the equivalent of 1/2 divided by 3/4 will give you the width. And then you see here the procedural move to change the divide into a multiply and to invert the fraction. So we change 3/4 to 4/3, and then we do multiply straight across, and you get 4/6. And although it's not reduced, it's correct. And so the beginning part up here is all about procedure. I think this area model down here is less developed than this one. It may have been a first draft, so let's look at this one. But before we do, let's look at this. There's a little bit of confusion here. 1/2 of 3/4 equals 1/2 times 4/3. That's not accurate. This of is a multiply. That's not really what they're trying to do. They're trying to say 3/4 of something is 1/2. And they're not sure what that is. So there's something confusing here, because this would be a multiply, and so we would not then invert and then multiply. But you can see that this is a follow-through from up here. At any rate, the area model, what they're doing here is they're taking one whole unit and breaking it both into halves. So the 4 dots represent a half, and then break it again into 3/4, which is the shaded area. And you'll notice again that that common denominator of 8 shows up, because this whole rectangle here is broken into 8 equal parts. So when you're trying to find the answer to the question, though, it's how many 3/4, how many times does the shaded region fit into the 1/2, the dots? And you can see that, again, the shaded region is represented by 6. That's how big a 3/4 is. And 1/2 is only 4 units. So 1/2 is 4/6 of 3/4. And that's what really I think they were looking for up here. 1/2 is 2/3 of 3/4. And there's the answer written again as 4/6, which can be reduced. But it's a good example of both the procedural information and the area model. As I alluded to earlier, I think the area model is a little more confusing than the double bar chart for this problem, because we're used to looking at this rectangular area model as this multiply and trying to interpret it one way, whereas in a division problem, the interpretation of this area model is completely different from what you're doing when you're looking at multiplying. Finally, here's some mathematical writing by a student. We can see it's fairly procedural in nature, but really explains the problem well. Here's your 1/2 square mile of area, and the length of it is 3/4 given, and the thing we need is x. And the student recognizes that the question is, what number times 3/4? What number times 3/4 gives us a half? Or 3/4 times what number equals a half, written a little bit more symbolically. To begin, the student is noticing that if you take the number and multiply by 3 and then divide by 4, you get a half. That's basically what this says. Take a number, multiply by 3, divide by 4, and you'll get a half. So to find x, reverse the process and undo the multiply and divide by using the opposite operation. So the student has the idea right. We're trying to undo this multiply and this divide. The proper term here, instead of opposite, should be inverse, by using the inverse operation. But they've got the idea, and that's what's important. It is helpful to make sure that they get the right language and use the word inverse there. They've got the concept, but may work with the language and make sure they use inverse here. At any rate, they're going backwards, so starting from 1/2, instead of dividing by 4, we're going to go this way now. Instead of dividing, they multiply by 4, and then instead of multiplying by 3, dividing by 3. This is undoing this multiply right here, and this multiply by 4 is undoing that divide right there. And they're doing both of those to a half, starting with a half, and they'll get x. So now they just work it out. 1/2 times 4 is 2. 1/2 of 4 is 2. And then you take your 2 and divide by 3, and you get 2/3, which is x, which is the width of the land. The land is 2/3 mile wide. So a very good and concise description with a lot of good language. This is really good mathematical thinking language. They're showing the process, even though they're not writing it out in words. They're showing the process of what they did, and that's equivalent. You know, we want to encourage our students to use English words and symbols and pictures and diagrams and all kinds of things, and that's what we mean by mathematical language, is basically to communicate your thinking in whatever way you can.